let's take a look at solving some exponential and logarithmic equations that use U substitution. And so I'm going to give you two good examples so that you can kind of recognize them when they come up. So this first one, right, the key thing knowing that you have to do U substitution is this log base 5 of x in parentheses squared. Once you see that, you can't really just solve it like a typical logarithm where you're setting the log equal to a number and then converting to exponential. You're going to need to use U substitution. So let's start by simplifying a little bit. If I'm just going to do one step here before I do the U substitution. I'm going to go ahead and bring this 2 down. Now notice how this one is different than this because it's not in parentheses. And so that means that the x squared here, the property of a logarithm, allows us to bring that 2 down and multiply it in front of the logarithm. And that's just going to be helpful when we do the U substitution. So now we're going to say let u equal log base 5 of x. Okay, so if I want to solve this now, I'm going to now rewrite my equation here with u. Okay, and now I just have, I'm going to go ahead and move this over. I always want to set something equal to 0 when I'm going to solve. And now I just have a pretty simple quadratic to solve here. Keep in mind, this is not going to, we're still got more work to do after this, but we can get u pretty easily, right? So we're going to get u equals 3 and u equals negative 1. Now, that would be nice if we're done, but we're not done, right? We needed to solve for x. So we're going to go back up here, and remember we said let u equal log base 5 of x. Well, now that means log base 5 of x equals 3 and log base 5 of x equals negative 1. Okay, now it's pretty easy actually, right? Because we're going to convert to exponential. Remember the base is the base here. 3 becomes the exponent, and x is our answer, right? So we know that 5 cubed, 5 times 5 is 25, times 5 again, it's going to give us 125. And then here, I'm going to have x equals 5 to the negative 1. Well, 5 to the negative 1 is just the same as 1/5. So we have two answers. Notice these are both positive, so they work fine with the logarithm, and we're done with this first one. Okay, let's do one more problem, and this is going to be an exponential equation that uses U substitution. So first thing I'm going to do here is, well, I always like to just get rid of the fraction, and so I'm just going to multiply. I'm just going to multiply both sides of this, right, by 3. So that's going to leave me with 2 to the x minus 2 to the negative x equals 12. Okay, now I'm going to go ahead and I'm going to write that in the denominator for a minute. And here's where I'm going to say let u equal 2 to the x. Okay, because we can't just solve this so easily. And really, this is the actually fastest way to do it. Okay, so we're going to say let u equal 2 to the x. All right, so let's go up here and rewrite our function now. So now we have u minus 1 divided by u equals 12. Okay, and at this point, I'm going to go ahead and bring this over. And actually, you know what? First, I'm going to multiply by the whole thing by u. And that's going to get rid of my fraction again. So I'm going to have u squared minus 1 equals 12u. Okay, so now I'm going to bring the 12 over. And notice we don't have a nice quadratic here where we can factor. So we've got a couple options. We could do quadratic formula, but I'm going to go ahead with completing the square. In order to do that, I'm going to know that I'm going to have a number I need to add here, and I'm going to bring the 1 over so that I can just add that same number on the other side. Okay, as long as when you're on the opposite sides of the equal, you're going to add to both of them. Okay, but if you had everything on this side, you'd have to minus before the equal sign. But remember, just a little quick review to find this number, right? If you want to complete the square, you do half of 12 is negative 6. Negative 6 squared is going to give me 36. And so that's how I know 36 is my number. So I'm going to go ahead and put that in. And now I'm going to have u minus 6 quantity squared, because that's what this would simplify to, equals 37. And I'm going to take the square root of both sides. And when I do that, I'm going to have u minus 6 equals plus or minus square root of 37. And that means that u equals 6 plus or minus square root of 37. Okay. Now, this is what u equals, right? But we need to solve for x. So now we're going to go ahead and we're going to put this back in. We're going to have 2 to the x equals 6 plus square root of 37. And our other solution, 2 to the x equals 6 minus square root of 37. Notice, if you look here, you cannot have 2 to the x equal to a negative number. And that's a problem, right? Because 6 minus square root of 37 is just slightly, square root of 37 is just slightly greater than 6, which means you're thinking like 6 minus 6.1. It's not exactly that, but it's somewhere around there. And that's going to give you a negative number. So this doesn't work. So this is extraneous. It's just we can't do anything with that one. But this one we can actually solve, right? So you get two choices here, and honestly, I like to just think about converting this back to logarithmic form, because we're going to have a log with a base of 2. The answer is going to be, the exponent is going to be x here, and then we're going to have 6 plus square root of 37. And that's my final answer. Okay, there's nothing more you can do with this to simplify. So you're just going to leave this here. You have log base 2 of 6 plus square root of 37, and that's what x equals.